Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with cold protective clothing. So, we will discuss the different fibers used for cold protective clothing. So, both the natural and man-made fibers, synthetic fibers are used. So, in natural fiber, most commonly used fibers are wool, down, feather and traditional other materials are being used for cold protective clothing, and these fibers are used basically they can entrap large quantity of air within their fibrous structure. In between the fiber, the space wool, mainly due to the crimp present in wool. So, it can entrap large volume of air, so that that air acts as insulator. Now, merino wool or maybe some other type of coarse wool are also used here. So, it moisture management capacity is very good, and it is odor resistant and temperature regulation. So, temperature regulation it is very important characteristics of wool fiber, particularly for extreme cold climate condition. So, it is this fiber is hygroscopic in nature, and while absorbing the moisture, it actually releases heat. It its a heat of absorption is there for wool is very high. So, if the moisture changes, it releases heat. So, that will give the warmth to the wearer. So, its moisture regain is typically 13.5% moisture regain. Natural crimp is there, which creates air pocket, as I have just mentioned. So, it is used for base layer, middle layer or socks. So, base layer, inner layer we can use this fiber due to higher moisture absorption, and middle layer we can use for creating the air pocket insulating layer. And goose down is also one very widely used for extreme cold climate clothing, and it is very light. So, warmth to weight ratio is very high. So, it with a small weight, it can give high it can create high pores, okay. And so, feel power is 600 to 900, and its good natural resilience is there. So, it is basically when it is wet that this the warmth is lost. So, alpaca is a fiber which is hollow in structure, okay, and that will and it is water repellent fiber, and natural fiber water repellent is there, hollow fiber. So, it has superior insulation and soft handle, and it is used for luxury outer garment due to its better look, better luster characteristics. Cashmere is ultra fine fiber, 12 to 19 micron, excellent drape it can create. So, superior softness due to lower micron, and good insulation it creates, but main problem is limitation is high cost and durability concern. It is not that durable because of the high very fine fiber, it damage easily. Now, engineered material, the synthetic fibers, polyester is very widely used, it is hydrophobic, quick drying, and thermal conductivity is 0.04 to 0.06, and it is used for base layer insulation fill, like your hollow polyester is very widely used for insulation material fill, and outer shell it is used due to its high strength and abrasion resistance. And nylon is also used high strength and high abrasion resistance. Nylon's main advantage is that it is high abrasion resistant, thermal conductivity is more than the polyester, and it is a shell layer it is used for outer layer. Because of the high abrasion resistance, this fiber is used due to high strength. The reinforcement areas are all those in the reinforcement area, this fiber is used. Polypropylene is also used due to its low density and superior wicking characteristics, okay, because its absorption, moisture absorption is almost 0, but its wicking characteristics is very high, and thermal conductivity is moderate. Base layer, outer wear, underwear we use, because where the in underwear polypropylene's main advantage is that if in case of sweating it actually wicks very fast and keeping the body dry. Acrylic is also used for cold climate clothing. So, wool like feel, lightweight, and it can give the warmth. Thermal conductivity of acrylic is low, 0.06, typical like polyester fiber. Application fleece, knit insulation. So, all these applications we use acrylic fiber. And advanced synthetic fibers are also used with the different cross sectional shape and diameter. So, microfibers are used, the denier of the microfiber is less than 1 denier, sub-denier fibers are used, and hollow construction. So, fibers with hollow structure, so which entrap air filled core, which enhance the insulation, and also bicomponent fiber. So, the different materials are there with for different performance. So, bicomponent fibers in outer layer, if we use it is a low melt fiber, and we can create porous structure and modified cross section. This is used for mainly high active situation for inner wear, inner undergarment. There in case of sweating, it will immediately wick the water, liquid like sweat, and the surface remains dry. So, microfibers fiber technology, the subdenier fibers create dense insulation. Okay. So, this create dense insulation, and the denier is less than 1 denier, we call it as micro denier. To increase the packing density, okay, and the surface area, generates fine porous network that enhance steel air entrapment and reduce the convective heat transmission. So, it becomes compact, and within this compact structure the air is entrapped. Air entrapment enhance the conductive heat transmission, and as this yarn and structure becomes compact, that it is reducing the convective heat transmission also. So, for the windy condition we can use to reduce the convective heat transmission. High surface to volume ratio improves the radiative heat attenuation. So, that is important. So, it will actually absorb the radiative heat. So, lower thermal conductivity. So, K effective thermal conductivity is equal to that, this is the basically, and in additive in nature. So, this is porosity is epsilon. Dense microfiber assembly improves insulation, okay, insulation by minimizing the pore size. And which is suppressed air movement according to Darcy's law. So, that is the dense microfiber, where Q is the airflow, K is the permeability, and mu is the air viscosity. Now, hollow fiber construction. So, air filled fiber, this air is filled inside the structure. So, which enhance the insulation. So, hollow fiber incorporated air filled lumen, this is center core part, creating low conductivity. Trapped air volume increases the fibers overall thermal resistance. So, the polymer has its own thermal resistance, but if we entrap air, the overall thermal resistance of the fiber increases. The effective thermal conductivity of hollow structure can be approximated by this formula. So, effective thermal conductivity K effective, and this is the fibers conductivity and air's conductivity. So, depending on the porosity, so that we can, so K and here is the porosity is there. So, that we can control the phi is the hollow ratio. So, if the hollow ratio increases, then the effective thermal conductivity will, you can see that hollow ratio. So, that K here we can control the thermal conductivity by controlling the hollow ratio. So, bicomponent fiber, dual polymer composition is there. So, combined two polymer. So, here you can see core sheath type of polymer, where with different characteristics we can use. So, thermal bonding capability, the different melting points allow heat induced bonding without adhesive. So, in sheath fiber is like blue color, it shows that it is a sheath fiber with a melting point 110 to 130 degrees Celsius, and the core polymer is that is polyester around 250 to 270 degrees Celsius. So, accordingly this fiber will ultimately if we form a non-woven structure web, and after the heat treatment, the sheath fiber will melt and form the structure which is stable structure. It will so it enhances the mechanical performance. Okay. Modified cross section. So, normally we get the circular cross section, but we can, if we modify the cross section, so it enhance the shape factor. So, effective surface area. So, specific surface area per unit mass of the fiber will be much higher. We can enhance the surface area, and by modifying the cross section, which enhance the wicking. So, increase surface area, here the unique cross sectional shape like trilobal, hollow, multilobal, okay, can increase the surface area by around 20 to 35%, maybe much more than this also, enhancing the moisture absorption. So, that liquid moisture absorption it enhance, and also it will enhance the wicking characteristics. It improves wicking. Okay. So, immediately it will reduce due to the more surface area, the wicking is increased. So, enhanced fabric performance. So, optimized fiber to fluid interaction improves. So, that will give the thermal regulation characteristics, and also one is it reduces the stickiness with the skin, that is the clinging effect, clinging behavior, it does not it is reduced in case of wet. When the skin gets wet, it immediately absorbs moisture, it will transmits moisture, skin become dry and clinginess reduces, and that is enhance the tactile properties, hand value. Now, if you see the comparison, natural and synthetic material comparison, so thermal performance matrices, so goose down and synthetic, if we compare, so warmth to wet ratio in goose down it is a 9 to 12 kilo per kg. For 1 kg goose down we can create 9 to 12 kilo clothing, whereas synthetic it is a little bit less, 6 to 8, advantage in down 25 to 50% lighter. So, in lightweight, if we want warmth, so we should use the goose down fiber, but it is expensive, much more expensive than synthetic fiber. And compressibility, its compression ratio is 8:1, it is highly compressible, and synthetic fiber it is 4:1, relatively low. So, goose down is it is we can superior packability, we can pack the fiber. So, it is we can compress it to a very small volume, little volume. So, total jacket made of goose down can be compressed to a very low volume. So, 1:8 you can see, and weight performance. So, goose down 90% insulation is lost. So, weight performance is not very good in case of goose down, but synthetic it maintains 70 to 80% insulation, only 30 to 40 20 to 30% insulation is lost, but in goose down only 10% insulation is kept, only 10%, 90% is lost. So, synthetic material performs better. Durability of goose down is high, 10 to 20 years lifespan with care. So, because as it is natural, so it is it can 10 to 20 years lifespan, but in case of synthetic fiber it degrades, maximum 5 to 10 years typically lifespan, okay, down with a longer service life. Cost benefit, you can see goose down is much more expensive than the synthetic fiber. So, now material limitation and challenges, performance trade off. So, all materials compromise between thermal performance, their weight, cost and durability. So, this we have to compromise somewhere. If we want lightweight and high thermal resistance, then cost may be high. So, that we have to see which part we should compromise. So, natural materials, the limitations are actually it down insulation, complete performance lost when it is wet, and goes down its wet. In case of wet, the thermal insulation is lost, its cost is high, and main problem is the ethical concern. So, can we use the goose down and its availability is very less. We cannot directly pluck this fiber from the any live bird. So, that will be its ethical issues are there. And wool fiber as actually it's due to its high moisture absorption, it's heavy when it's wet, okay, and as it water penetrates, its drying is very slow. So, that is the problem of wool fiber, and it has potential shrinkage is there. Cotton is poor thermal properties, so it is not that insulating. Moisture retention, it actually retains moisture, it drying is very slow, and the risk of hypothermia. So, that is the problem of cotton material, and natural variability is there. So, we cannot get the consistent characteristics, consistent property we cannot get, because it is batch to batch the performance varies. The synthetic material, main challenges with the synthetic material is weight penetration. So, 25 to 50% heavier than down. So, for same warmth, okay, equivalent warmth, the weight is heavy, it is around 25 to 50%, and permanent thickness loss over time. For normal fabric, permanent thickness loss is there, but if we use the bicomponent fiber with this through air bonding, then the structural integrity will be there, will be high. Thermal degradation, performance loss at high temperature. So, that due to the thermal degradation, and in case of cold extreme cold condition, this thermal degradation chances are less, but in sub-zero condition for long time if we keep, so that fiber get damaged at extreme cold condition. So, and static built up. So, and static charge in a dry atmosphere, the static charge generation is there. Now, oven versus knitted construction. So, after this fiber, now the fabric characteristics. In oven fabric properties, the structure is interlaced warp and weft yarn. So, dimensional stability is high, wind resistance and durability is very high. Okay. That is the advantage of oven fabric, and application is mainly in shell fabric, outer layer fabric, because of its compact structure and the abrasion resistance and all these things will be high. Even in oven structure fabric, the tear resistance, tensile strength will be high. And knitted fabric, locking loops yarns are there. So, it is main advantage here is it is stretchable. So, and it is comfortable. So, in inner garment we can use the knitted fabric. So, like base layer, fleece or comfort layer we can use. And performance comparison, thermal properties, knitted fabric traps more air. So, it gives better insulation, and but oven fabric, due to its ability to have compact structure, So, wind barriers there, high wind barrier, and mechanical properties. The woven fabrics have higher tear strength and knits have better stretch and recovery. So, we can use the woven fabric as I mentioned as outer layer and knit as inner layer fabric. Knitted fabric is more comfortable than woven fabric due to the fact that it conforms our body movement. So, it does not restrict the movement of our body parts. Now, a specialized construction, first is the ripstop weave. Ripstop weave is that is used in outer layer. So, where the reinforced threads are used here to prevent any tear propagation. We have initially we have discussed the ripstop weave in detail, and fleece knit brushed surface. So, we can use the knit fabric with a loose low twisted fabric, then we brush and to create the long hairs on the surface which entrap the air. So, entrap this air brushed surface and which provides the insulation, and 3D knitted structure create insulation layer, and warp knitted if we need if we want any fabric with dimensional stability, and that in that case we can use warp knitted fabric also. Now, see the ripstop weave. So, reinforced threads prevent tear. So, these are the reinforced threads, thick, it may be thick threads or maybe any strong yarn can be used, and that will actually prevents the tear propagation. We can use in both the directions, we can use. Higher tear strength, ripstop weave increases the tear strength, tear force from 45, it can go up to 65 to 70. So, 40 to 50% improvement in tear strength by only by incorporating the reinforcing threads. Slow tear propagation. So, reinforcement threads every 5 to millimeter stops the tear propagation. Efficient strength to weight ratio. So, adds 3 to, so we can add 3 to 10 gram per square meter. So, due to the reinforcing thread, but improves the resistance tear resistance to 2 to 60%. So, that is important. So, here you can see 40 to 50% enhancement in the tear strength. Now, so here actually basically it is a typical 20 to 60% increase generally if we increase the weight. So, typically it is around 40 to 50% improvement in tear strength. Now, fleece knit structure you can see the knit is brushed to trap additional air. So, this is used as a in the inner side of the fabric just to for any the winter wear. So, it entraps the air. So, that helps in improving the insulation. So, air trapping for insulation, brushed fleece surface traps 20 to 30 gram per meter cube, that much air it traps, improves the thermal retention and keeping wearer comfort. Lightweight warmth, despite added insulation fleece fabric remain light. So, 150 50 to 300 gram per square meter for comfort and mobility. So, you can have lightweight, it gives warmth and enhance softness and hand. So, due to its the fleece structure, so it enhances softness, brushed increases the surface fiber height from by 1 to 2 millimeter, improves tactile and touch sensation, and specialized construction like spacer fabrics are used, 3D spacer fabric, where the between two layers of knitted fabric the spacer yarns are incorporated, which are typically in vertical orientation, which allows the air large quantity of large volume of air to be entrapped within this structure between the two layer. So, 3D insulation layer is there, the knit structure creates 2 to 5 millimeter air layer. Okay. So, and improving the air insulation by typically 15 to 25% compared to single layer fabric. If we have single layer fabric, the for same layer, so if we bring this two layer close to that, so for same weight, so the it will be it will have more insulation due to this steel layer entrapment. So, breathability is also improved. So, because of the pores in 3D structure allows the moisture vapor to pass through. So, transmission is as high as 2 to 2.5 kg per square meter in per day, which reduces the sweat accumulation, and also it improves the cushioning property. So, while compression it will be compressible, and also it will the resilience is good, and spacer fabric provides compressive resilience up to 30 to 40 kPa, offering better comfort and reduced pressure to skin. And for warp knitted, if we want the dimensional stability in the structure, so we can use the warp knitted fabric. This exhibit low shrinkage, less than 3% after washing, dyeing. It is controlled stretch, provide 20 to 50% elastic elongation along the course or well direction, maintaining the shape under tension, durable in nature because high loop density. So, it is a much more durable than web knitted structure. Now, nonwoven is widely used for extreme cold climate clothing. The sheet or web structure bonded together, okay, by the entangling the fibers or filaments mechanically or thermally or chemically. So, by bonding the fiber in mechanically is by entangling, or filaments are bonding by thermal means or chemical means. So, manufacturing process are spun bonded nonwovens, continuous filaments are laid. So, and then melt blown fine fiber wave from the molten polymer is extruded at very high speed, and then it is through air, blowing air, and it is the filaments got stretched, and then they form wave. Needle punching by mechanically entangling the fiber with the help of barbed needle. So, if we see the needle, so this type of barbed needle will be there. So, this is a needle construction, and these barbs when penetrates through the web, they take the fibers along with that and get entangled. Fibers are like this is the fiber web, and the due to the penetration of the needle, this fibers from the top moves downward and there is entanglement takes place. Thermal bonding by maybe by calendar, heat calendar, or maybe the high temperature air blowing. So, partial melting take place and the fibers get bonded together. Now, these are advantages, commercial technologies are there. So, the Thinsulate is a technology, or Primaloft, there are different technologies are available. The spun bonded nonwoven technology, high strength to weight ratio. So, due to its continuous filament, as continuous filaments are there, so high strength to weight ratio is there. Uniform and isotropic structure, because the wave is formed by the continuously following the on the conveyor belt in a continuous manner from the spinnerets, series of spinnerets. So, that is why the its structure becomes uniform and isotropic. Controlled porosity, we can adjust the porosity depending on our requirement. So, for filtration, breathability, so for many applications we can use this. Versatile and scalable. So, we can use for apart from the this extreme cold climate clothing. So, we can use this hygiene product, mechanical, medical, agriculture product, in geotextiles widely used. Now, melt blown nonwoven, where we can have very thin structure, although melt blown is not in that popularly used in extreme cold climate clothing, but one of the layers one can use in the melt blown for some special purpose, produce fibers from 1 to 5 micron diameter, much finer than spun bonded, increases surface area. It is basically used for filtration, filter fabric, high filtration barrier, low basis weight. We can produce very fine, very lightweight fabric, and composite application. So, there is a spun bonded, melt blown spun bonded structure is mainly typically used for hygiene product. Now, needle punched nonwoven, as I have mentioned. So, mechanically entangled. So, barbed needle with the barbs repeatedly punching. So, this is the barbed needle. If repeatedly punch the structure, so here there is a needle board will be there inside. So, there needles repeatedly punch through the web and creating interlocking network. High loft and permeable clothing. So, it is very bulky, and this can be and here it is a porosity is there, air permeability is high, but it is insulation, for insulation purpose, insulating layer we can use the needle punch fabric in case of extreme cold climate clothing, and we can use any fiber. So, maybe synthetic, natural fiber, high performance fiber, depending on our applications we can use any fiber here, because the bonding is by only needle mechanical bonding, and thermal bonding is also there by heat calendar, heat pressure we can use. So, heat activated fiber bonding. So, the fibers particularly here the fibers can be bicomponent fiber or thermoplastic fiber typically or low melting fiber, like polypropylene is very widely used for this thermal bonding, and it is heat and pressure. With the help of heat and pressure, the fibers are partially melted and the bonding takes place. We can control the bonding pattern, we can create the different structure like dotted bonding or depending on the calendar shape. Here in this calendar shape you can see pressure calendar, heated pressure calendar, it is a dots are there, okay, that this protrusion is there, and only the heated portion at those dot the fibers will get melt. So, here this type of structure will be there. If we want the this type of fiber which is basically bulky porous structure will be there, but except this dot portion where melting took place, rest other portion becomes will not, it will be basically porous structure. So, it can entrap air and that fabric becomes soft. So, energy efficient process, so high speed, okay, at solvent free process, only heated cylinder is there, heated calendar is there, and we can produce a lightweight technical textiles. And the surface treatments are there, various surface treatments are used, padding applications. So, immersion in treatment solution. So, we can just in treatment solution we just immerse the fabric and then or by spraying the coating, surface coating application, or foaming, reduced chemical usage is there, we can use the foam or plasma treatment, gas phase surface modification is there. So, we can do all these applications for maybe for durable water repellent finish, for any protective clothing. If we want durable water repellent finish, in that case we can use this the surface treatment characteristics, the method, and surface water beading and shading is there. So, surface water will be removed and fluorocarbon or silicon based surface treatment can be used. Antimicrobial treatment is very much required for extreme cold climate clothing, because the people who are working were using will be using these things in extreme cold climate condition, they will be wearing for long time without washing. So, for that antimicrobial treatment is important to control the odor and maintain the hygiene. Silver ion, zinc and various other chemicals are used. Anti-static finishes are there. So, to reduce the static charge build up, and then UV protection. So, we can use the UV protective UV blocker, and UV actually radiation is very harmful for human being. So, we can use the UV blocker for to prevent it from any harmful radiation. Okay. So, UPF value we can improve by UV protective coating. So, surface treatment by 50 to 50 plus. So, we can increase the UV protection to a greater extent. So, by absorbing the UV ray or by reflecting the UV ray. So, that type of surface treatment we can use, and then waterproof breathable structure is required at least for the outer layer. So, that is waterproof breathable membrane technology is being used widely. So, membrane function is actually selectively permeable barrier that blocks liquid water, but which allows the water vapor transmission. That is basically true for the moisture barrier layer which we have used for thermal protective clothing. Here also we need the waterproof breathable type membrane, because in case of snow and in any other condition, suppose in extreme cold it is raining. So, the inner garment, the water should not penetrate inside. So, outer layer should be treated with the this any membrane, that waterproof breathable membrane. So, membrane type, it depends on microporous. So, physical pores are smaller than the water droplet, so that water droplet it does not penetrate. It should be hydrophilic. So, hydrophilic chemical absorption and desorption will be there. Combination microporous with hydrophilic coating. There are few commercial technologies available. So, Gore-Tex is one that is microporous waterproof breathable system is available. So, expanded poly tetrafluoroethene PTFE, it is microporous and performance 28,000 plus millimeter water column. This is very high water waterproof, but breathability is RET value is less than 6 meter square Pascal per that is the RET value. Another technology E-vent is technology, which is direct venting PTFE, durable water repellent, okay. It's which is not no durable water repellent finish required, because the membrane is itself is water repellent, superior breathability due to presence of pores inside the structure. Sympatex, another technology which is hydrophilic polyester type membrane is used, 100% recyclable and performance temperature response responsive permeability. Neocell air permeable membrane, enhance air circulation and application high active use. So, these are the different waterproof technology. Now, in case of extreme cold climate clothing, so multi-layer technologies, multi-layer system is used, like in case of the extreme heat protective clothing. So, here again outer layer, middle layer and inner layers are used for extreme cold climate clothing. So, human body it generates the heat and moisture. So, it should prevent the heat flow to outside, at the same time it should allow the moisture vapor from the human body to outside. So, extreme cold weather clothing on the basis of there are different layers on the basis of their functionality. So, base layer, which is inner layer, responsible for wicking of moisture, sweat away from the. So, this is the inner layer, base layer, which is responsible for absorbing the sweat, and it should immediately transfer this sweat to the next layer to keep the skin dry. and it helps in preventing the chill by keeping the skin dry. So, as the skin dry, so the chilling effect will not be there and minimize the heat loss caused by moisture evaporation. So, that is important here. From the body, if the moisture gets evaporated, then it will take the latent heat from the body. So, that we are trying to keep the body dry. So, immediately it will transmit the moisture vapor, and mid layer it provides the insulation. Mainly this is the layer which provides the insulation. So, where air pockets are created, trapping the body heat while allowing the moisture to move out to the next layer. So, this actually heat trapping is there. So, it will provide main insulation. Okay. Compression recovery. So, this structure is created in such a fashion, if it is compressible and at the same time it is resilient. So, that type of structure it is created. An outer layer which will be actually typically protective layer. So, protect the wearer from wind. So, wind shield effect should not be there. So, it should be compact in structure. It should be protected from the wearer should be protected from rain. So, it should the coating should be there. So, waterproof coating should be there. It should be waterproof or snow. So, while still being breathable. So, it should be that the coating should be the breathable coating. So, allow the moisture to escape. So, what it is doing? It is allowing the moisture escape, but at the same time it is preventing the water or snow to come in, get into the structure, okay, the fabric structure, and it is the human body is protected, and it protects from heat loss caused by wind chill. So, as the wind it is wind protected. So, wind it does not allow the wind. Okay. So, during the any air movement, it will not allow the air to take the convective heat from the human body. So, it is protecting against the unnecessary loss of heat. And the multi-layer system is there. System integration principle, it optimizes the interaction between layers to maximize overall system performance rather than the individual layer. So, individual layer can work its can have certain performance, but as we have already discussed, the multi-layer system it enhances the performance of one layer by incorporating other layers. Okay. So, that is the multi-layer system integration should be there. So, layer interface consideration. So, layer interface should be there. So, vapor pressure gradient, maintain moisture driven from inner to outer layer. So, that vapor pressure gradient should be there. So, multi-layer should be selected in such a fashion the moisture vapor from the inner side of the body should move freely to the outside. So, vapor pressure gradient it should be able to create, and thermal resistance distribution. So, balance insulation across the layers. So, that this we have to select judicially. So that the vapor pressure gradient is created properly, and thermal resistance distribution should be proper, air gap measurement. So, we can control the air gap by controlling the convective loops actually between the layers. And mechanical compatibility. So, it minimize restriction and binding. It should be mechanically compatible, like one fabric, if it is we are using say knitted structure, another layer if we use this woven structure. So, let us see, suppose this is a knitted structure and another layer we are using say woven structure, this is woven structure. So, woven structure will not be stretchable, but knitted structure will be stretchable. So, the mechanical compatibility is not there. So, if we use this in different layers, so knitted structures extensibility will be restricted by the woven structure, because it is not stretchable. So, that type of we have to see the compatibility between the layers we should consider during designing. So, what are the challenges during integration? The moisture management. So, that is prevent condensation between layers through proper vapor transmission. So, it has been observed that if the this layers are not properly maintained and that properly selected, then the moisture get condensed, moisture vapor get condensed within the structure, and particularly in extreme cold condition, if the moisture vapor gets condensed within the structure gets wet. It because moisture vapor gets the condensed to the water. So, that gets wet and immediately the thermal insulation drops. So, that will be reduce the performance. Thermal breezing. So, minimize the heat loss, it should be able to minimize heat loss by seams, zippers and construction details. So, that we should select the seam in such a fashion that should minimize the heat loss, and zippers, the heat loss should not be there through zipper, seams and different other construction. There should not be any undue ventilation like bellow effect. Through bellow effect the heat loss may take place. So, that those constructional structure we have to details we have to create, like some your elastic band should be used to trap any opening. Mobility restriction. So, multiple layer can compound movement limitation. So, that is we have to see that it should not restrict the movement. So, this the total structure should not be bulky. So, that way we should be careful in selecting all these structures. And weight accumulation, total system weight after use affects the user performance and the comfort. So, that is total weight we have to consider. So, if we want higher thermal insulation, it is not necessary we have to use very thick material to get the higher thermal insulation, but at the same time we should see the total weight of cloth should not affect the user's performance and also comfort, mobility of the ergonomic comfort, mobility of the wearer, that we should take care. And this after this multi-layer. So, we will use we will see the other material, advanced material use. So, we will stop here up to the multi-layer system integration, and in next session we will start with the phase change material, okay, and which is used for in the extreme cold climate clothing also. Till then, thank you.